Hey kids, we're going to go through a quick video explanation of problem set A3. The first thing just wants you to show, so you got to show your work, that the derivative is 3 minus x over y squared minus 1. So all I'm going to do is I'm going to take the derivative of this. Just remember the derivative of 2y cubed is 6y squared dy dx. And then there is no product rule or things like that going on here. So we just got to remember anytime I take a derivative of y, it's dy dx, and the derivative of anything with x is just as normal. And also the derivative of 12 is going to be 0. Solve for dy dx, and you're done with the problem. Part B, you want to find where they have a horizontal tangent. So the derivative from the first part, which is already given, is 3 minus x over a y squared minus 1. So just remember a few things. When the horizontal tangent, I need the derivative to equal 0. Since I have a rational equation right here, when the top is equal to 0, the entire thing is equal to 0. When the bottom is equal to 0, it would be undefined slope, which would be a vertical tangent. So all I do on this problem is I set the top equal to 0, because that's when the derivative is equal to 0, and that's where you'll have your horizontal tangent. For letter C, we want the equation of a tangent line at the point 2, 3. So remember the two things we need. I need a point, which is 2, 3, and I need a slope, which is the derivative evaluated at 2, 3. So I was already given the derivative, which was 3 minus x over y squared minus 1. So plug in 2 for x, 3 for y, and you should get the slope of 1/8. Now the equation of the tangent line is y minus 3 equals 1/8 times x minus 2. So that's the equation of the tangent line. Now what I want to do is I want to use that tangent line to approximate the value of y when x equals 1.9. So all I'm doing here is I am plugging 1.9 in to the tangent line. Now, typically, I could leave my answer like this for the AP, and I believe I can do that this year as well, because I solved for y, and then that is going to be my value. You will have a calculator in which you could plug this in, so you could also plug it in and then give a more exact answer instead of leaving it like this. For letter D, I want to check the concavity at the point 2, 3. So concavity, remember, is when the second derivative at the point 2, 3, if it's greater than 0, it's going to be concave up. When the second derivative at the point 2, 3, if it's less than 0, it's going to be concave down. So I am going to take my derivative, which was already given, 3 minus x over a y squared minus 1, and I am going to take the derivative of that. So that will give me d squared y over dx squared, which is the second derivative. Here I'm going to use the quotient rule. So remember the quotient rule. So that's going to be low d high minus high d low, which is 2y dy dx when I take the derivative of y squared, all over low, low. Now I do have this dy dx, so remember, I need to plug this in for dy dx, then plug the point 2, 3 in and see if I am going to be greater than 0 or less than 0 in order to get my concavity. All right, the last one is a yes or no question, and we just got to show the results that lead to that yes or no of, is it possible for a vertical tangent at the points where it crosses the y-axis? So first thing, when I cross the y-axis, I know that x is going to equal 0. So if I plug that into here, I get 2y cubed minus 6y plus 0 minus 0 is going to equal 12. So this is what I'm eventually going to work with. Now, if I take a look at my derivative again, which was 3 minus x over y squared minus 1, I get a vertical tangent or an undefined slope when the bottom equals 0. So the bottom is going to equal 0 when y is going to equal plus or minus 1. So I know that y has to be plus or minus 1, and I also know that to be on the x-axis, this is the equation I'm going to deal with. But what I'm going to do is I'm going to plug plus or minus 1 into here. So if I plug a positive 1 in, I get a 2 minus 6 equals 12, negative 4 equals 12. Well, that doesn't work out. So I know when I plug a positive 1 in, I cannot have a vertical tangent. And then let's plug a negative 1 in. And when I do that, I'll get a negative 2 plus 6 equals 12. I get a 4 equals 12. Well, that's not true either. So it looks like there is no possibility for there to be a vertical tangent line when the point crosses the y-axis.